Yes. So Thi Hong is a Malaysian based in Singapore. Is working for the Ministry of Health of Singapore. And I think we can start. Let's go on, Thi Hong. Thank you.
Thanks, Frederick. Hello, everyone. Good afternoon. I'm Thi Hong. Thank you very much for the opportunity. Extremely grateful to be here to share on this topic. It's a topic of passion of mine. And this topic is about this actuarial loss prediction Kaggle competition hosted by Singapore Actuarial Society. And I'm the third place winner for this competition. I'm a little bit about myself. I'm an actuary. I train predominantly in the life insurance industry. And yeah, so this presentation of mine, I will focus more on my personal journey, a story of mine in this competition, and try to reflect on it. Why is it very fruitful for me, rewarding, and also why is it a very effective way to learn machine learning? And towards the end, if I have a little bit more time, I'll touch on some key aspects of my technical solutions. So yeah, once again, thank you very much. And now let's dive in. Yeah, so machine learning, it's a buzzword, has been a buzzword with us for some time now. It has also piqued my interest. I've become very interested in it for a long time already, but I just didn't have time to engage in this topic. I think like every one of us here, we were busy studying for actuarial exams, right? So where else can we find time to study another thing? So anyway, luckily I finally qualified, and then I finally have the time to engage in this topic. So I did it mainly through online courses. So I study online courses, maybe on the weekend, or sometimes when I'm lazy, I don't do it. But I did this kind of passive learning for about 3 years. And until this year, thanks to SAS, they hosted this competition, and I also very lucky to have the luxury of time to actually engage in this competition. I joined this competition, and yeah, from this competition, it gave me a very good realization. And although it's common sense, but this form of learning, active learning, and learning through practical application, learning through problem solving, it's so much more effective. It's very effective, engaging, and rewarding compared to my 3 years of passive learning. So this competition actually lasted about 3 to 4 months. So yeah, to put into context, 3 to 4 months of intensive active learning through competition, I learned so much more compared to my 3 years of passive learning doing just online courses. So yeah, hence for this presentation of mine, I will try to focus on this aspect, like why is this form of learning, this going into competition, a very good way for us to actually engage this topic. So where can we find all this very interesting data science problem and well-crafted problem for us to solve, right? Ready to go problem. So it's for me, it'll be Kaggle. Kaggle is a platform, it's a website of it is also the biggest, I think the biggest data science community in the world. So on it, they host competitions on a daily basis. So if you log in now, you can see there will be more than 10 competitions going on, some with prize money, some without prize money. And the world-class top machine learning practitioner will all go there and compete on a daily basis. So a very engaging place. And yeah, and this is how the website looks like, just a taste of it, very minimalist. So this is also the page for this actuarial competition by SAS. And yeah, it's just like that. There's a few buttons here and there. You can click to download the data. You can look at the leaderboard for see how everyone is performing. You can also submit your predictions. Yeah, so for the next 3 slides, I'll just briefly recap the competition again, just briefly. So this competition is about workers' compensation insurance. So basically, if your workers get injured, and then they incurred hospitalization expense or sick leave, medical leave, yeah, this insurance will be reimbursed. And the goal of this competition is actually to predict the ultimate cost for each claim. So the key is each claim. So normally, I think traditional actually we normally do like Yili mentioned triangle, which on portfolio basis. But this one is actually we have to predict the ultimate cost for each unique claim. And yeah, and how do we know whether we are doing good or not? It's the scoring system is root mean square error, RMSE. So straightforward, it's just the average of your errors. And here's the leaderboard. This is how the leaderboard looks like. So our goal is to get the root mean square error as low as possible. So the lower our error, the better our score. And then we'll climb up the rank. And lastly, this is the data. So the data has already been split into two parts for us, the training data and the test data. So let's focus on the first table, the training data. So each row is actually a unique claim record. So there's about 50,000 unique claim records, and there's some demographic information about each claim, what's the accident date of the claim, and some claim description on the claim. And most importantly, to the far right is the ultimate cost. So this is the answer which we are trying to learn from. And then let's move on to the next table, test data. So if you look at the far right now, you can see that ultimate cost is missing already. It's no longer there. It's hidden from us. And this is what this competition is about. We will have to compete on this, who can predict the best predictions for this test data. So we will learn from the training data, and then we'll use our model to predict on the test data, and then we'll submit our answers. Yeah, so that's it for a brief recap and introduction. And now let's dive into to share my personal journey and experience, why I find it rewarding, and this kind of getting our hands dirty way of learning, like really writing the code and all that through competition is a very effective form of learning. So there's a 3 point I'll share. First point is, yeah, learning to code and think in Python. So these are all my personal beliefs. Anyway, so I have a personal belief that language limits or expands your thinking. What does it mean? It means certain language they have certain words or all that it will makes you form your thoughts easier, or makes you think about certain things easier, and the logical sequence of the language, the words that string together, can help you form the thoughts better. And I think this applies to Python as well. So Python is a programming language. It's also the language that I use for this competition. So my workings are all in Python. And yeah, I have to put a disclaimer that I'm not a coder. I don't write good code, so I struggle learning coding back in uni, and also in my day-to-day work, I'm working in the life insurance industry mostly, so we normally use Excel, and the most we do is just some Visual Basic just to automate the macro. So I'm not a good coder, and yet Python, it's so magical that it's fairly easy to use and very fun to use. So I think it goes back to the polling just now this morning by Suguru that actually most of us are interested in data analytics and this kind of competition, and it seems like the main hurdle is this kind of programming skills, right? But I must say you should give it a try. Python is actually much easier and much intuitive to use than you might think of. So but why, right? Why Python is easy to use, right? I think I try to reflect on it, and I think there's 2 points. First point is that it is somewhat readable. So Python, if you Google it now, then you will see that the language itself is actually, it reads almost like English. So you can actually already guess what the code means without even Googling all the jargon to know the details. You can sort of guess what it means. It reads like English. So what this allows me, at least me, to do is that, so whenever I have an idea that I want to execute for this competition, and then I'll just think in English, right? And then I'll just quite easily, I can translate it into Python code and start executing my ideas already. So what this allows is that it's like almost effectively I'm thinking in Python already. So in this way, it's like Python is like an extension of my thoughts, right? So maybe one point to strengthen this is that so this competition ended about more than 6 months ago, more than half a year ago, and then to prepare for this presentation, I have to dig back out my workings for the competition just to read at it. So my workings are very dirty, very dirty, no cleaning, no documentation. And this is lines of Python code, maybe hundreds over or 1,000 lines. And surprisingly, when I open the file, I can still read most of my code. It's still, I can understand my code. So I think this is the very magical part of Python. It's effectively the whole working file, it already reads like an English documentation to me. So I think this is why I think it's very somewhat readable, the code. And then another point is minimal. So I read somewhere that the developer of Python, that they actually have the philosophy of being minimalist. So their code are actually all very short, simple functions, very short and simple, and also very intuitive. So it makes this, I don't know, it just makes you easy to write in Python, because all the codes are so short. You can just keep trying new ideas and very fast, and it makes the whole process very interactive and very engaging. So most importantly, you can just keep prototyping new ideas because they are also so simple to just write. And combining these two, readability and minimalist, so this whole journey, this whole experience of working and thinking in Python has been a joy to me. And I really, now that I really like Python, that yeah, I'll try to use more of Python and less of Excel. So that's point number one of this why this practical way of active learning form of engaging in a competition is very effective. Another point is that it's the leaderboard. So it's the leaderboard is, I think it's a very good system. So to expand a little bit on it, the leaderboard is actually live, meaning for this competition, which spans about 3 to 4 months, the leaderboard is always there. There's a public leaderboard that's always there, and you can everyone can just submit their predictions, and then and then if it's good, your ranking will go up. If it's bad, if someone else submit a better prediction, they will go up, and then they will bring everyone else down. So it's a live leaderboard. It's ongoing all the time. So for example, like I submitted something today, and then it looks good, and my rank maybe 15th, and then I go to sleep, and some other competitors around the world will be submitting their predictions when I'm sleeping, and then when I wake up, my ranking would have changed. Yeah, so it's very interesting. And the disclaimer is that I'm quite a competitive person, so that's why I guess I find this part very engaging. So so what this live leaderboard allows me to do, right, I think is because it gives me a very powerful instant feedback mechanism. So I think learning to have a very effective learning, you would like to have your the feedback to come back as soon as possible, almost instantly, right? Like at the moment you have the idea, you executed the idea, you want to know whether the idea is good or bad, or is it a mistake, so you want to learn from it instantly. So this live leaderboard allows you to do that, because as you execute, you submit, you don't just get your own root mean square error, you also get how it compares to the rest of the competitors. So there's 2 layers of information that you can extract from there. And the second point is that yeah, so because this competition lasted 3-4 months, we have multiple opportunities to keep on resubmitting our answers. We can just keep submitting. I submit almost 100 attempts of prediction. So so each new submission, it's actually a brand new opportunity to me. It's a brand new opportunity for me to improve on my previous submission. So I guess this system actually encourages you, or even forces you to keep rethinking and keep regenerating new ideas to submit, and then pushes you forward, pushes you harder. So yeah, so I think this the very magical part about this leaderboard in helping us to engage this topic better. And here is just to illustrate a little bit on this sense of journey. So this is a plot of my score over this whole competition. The x-axis is the number of times I've submitted my predictions, and then the y-axis is my score, root mean square error. So the lower it is, the better it is. So you can see that my score is the blue line. It slowly, gradually go down as through time, as I make more and more submissions. And around the 60th submission, I break through the top 10%, and around almost towards the end, I break through the top 3%. So I thought this is a fun way to just show a little bit on, give a sense of the journey, how it actually kind of look like. And it also tells a little bit on sometimes I make big leaps in my model. I make good, meaningful changes, and it helps me jump the rank quite a bit. And sometimes there's a long stagnation that I have no meaningful gain. It's just persevering. Yeah, and lastly, the last point on this this reflection on why this active learning is pretty good is it's actually pretty simple. It's a very fun process. To me, this competition is like a puzzle. So you can just play. You're learning through play. Yeah. So no stress, very fun. And very importantly, there's a very good community, data science community on Kaggle. So for example, everyone actually is very willing to share on the platform. Like for example, right at the end of the competition, once the competition ended, all the top winners, all the top participants, they will start sharing their solutions there on the discussion page. You can what's their tips and tricks, what's their what did they do, what did they find out that got them to the top spot. So you can read all their solutions there. So there's an amazing page of top solutions there. You can just read. So it's such a fun way to learn, right? Because you already engaged in this competition, you know all the problem that you face in this competition. And finally, on the last day, when the competition ended, there's a whole page of solution, multiple different solutions you can read from to learn from. So yeah, this is just one aspect. Even before the competition ended, everyone is so willing to share. Some people will share ideas on how they think they will engage this topic. Some people will share their working. Some people will share analysis. And some people will even share their code, the code that they have written that's ready to go. You can just download and start playing around with it. So bottom line is the data science community is just very willing to share. And yeah, there's so much you can learn from there. And very lastly, to expand on this aspects of fun, right? So this actuarial competition on Kaggle is just one competition. There's so many more competitions on there that is very interesting and very diverse in topics. So here is just a very small subset, tiny fraction of competition. I just want to show, for example, that is available on Kaggle. And this in fact are the competitions that I've entered since the actuarial competition, because I got addicted. It's so fun, and then I just keep playing. Just briefly, I think because it's quite interesting. So the first competition is like Shopee e-commerce. So they hosted this competition where we have to from their images, we have to find out which of the two images is actually talking about the same product. So you have to match the image to the same product using computer vision. And then to the left, to the right, there's a competition on bird. It's very cute. So the data for this competition is actually audio clip. So inside the audio clip is actually the sound of forest, and in it there will be bird sound in it. So the challenge of this competition is to identify which bird species contained in that audio clip. And it's actually a very meaningful competition, because if it's done well, this technique can be applied to any forest in the world, and then they can record the forest and then apply machine learning to it, and then they can find out how many unique species of bird is contained in that forest. So from there you can imply the biodiversity of the forest, and hence you can say something about the health of the forest. So very meaningful. And then quickly, there's just Google GPS signal that we try to improve the GPS satellite signal and all that. And then there's a natural language processing competition where we try to extract information from research paper. And to the bottom left, there is a competition on Lux AI, which is a simulation game where we train an AI that will fight in a mini real-time strategy game, where our AI will go around and fight with other opponents. And then lastly, there's a ventilator pressure prediction competition, yet another very meaningful competition. So in this competition, we have to predict the pressure in someone's lung based on the settings on the ventilator machine. So if done well, it will be a very useful tool for a hospital. Yeah, thanks for listening to all that. And so just now I've been sharing the 3 points on Python, on Leaderboard, and on the fun aspect of engaging this thing through active learning. And it's more macro sense. So now let's zoom into the more practical reflection that I gotten out, the key takeaways for this competition, particularly this competition. Number one is actually speed. So in some point in time in the competition, I lost all my momentum and motivation. I didn't want to continue already, because my model became and then I realized what's the problem. Because the problem is my model became very long and bulky. And it takes 6 hours to run my model. It's just so slow. And because I think I did not do it, because I just Google everything that looks interesting. I just chuck it into my code, and then yeah, it becomes so long and very bulky. And then I revamped my code into a very light version. So I throw away all the so useful parts, throw away all those parts that takes very long to run, and then my code takes seconds to run. and magically all my motivation, momentum all came back. And then yeah, it's just very important. So from then on, I can try out many new ideas. One day I can try out 5 to 10 ideas, and because it's so fast, right? And then second point is on error analysis. So most of my ideas that I gotten from how to improve on my model is actually that came from looking at my current error. So I really dig into my errors and look at, okay, how come this particular claim my model is predicting very off compared to the answer. So and I try to drill in and have a little think about it, and then yeah, and then a new idea will pop up. And lastly, very important is on this actuarial in-class competition. So it's an extremely good place for most of us who are interested in machine learning to start on. Why do I say so? Because first of all, you can see that this morning the other competition is on car insurance, and for this competition of mine and Yili is on workers' compensation insurance. So they are both in insurance domain. So this kind of domain is really familiar to us, and it breaks down the barrier to entry by a lot already. So it's easy for us to get started on. And secondly, also the kind of data we are being challenged with in these two competitions, they are both structured tabular data. So meaning the kind of data we are familiar with rows and rows of record, column and column of variables, clean and structured data for us to work on. So another layer of barrier of entry that break down for us to get work on. Because why do I say that? Because most of the Kaggle competition currently online is actually centered around computer vision, so image data, or natural language competition on long form text. So these are unstructured data, which maybe us actuaries are slightly less familiar with, and maybe the barrier to entry is much higher. So extremely grateful to this SAS hosting this kind of competition for us actuaries to have a chance to start dipping our toe into this machine learning world. And yeah, so great place to start. I hope you, whoever interested is go there as well. Yeah, thanks for listening to all my babbling. Yeah, I don't have much time. Yeah, so 10 minutes left. I'll focus on my technical solution now. Yeah, my solution is also available online on Kaggle. You can go and read it in details if you're interested. Yeah, so there's roughly, I think once I reflected on it, there's roughly 3 sets of most meaningful modeling choices that I've made that got me to the 3rd place. And I think there's not much 10 minutes left, so I'll just focus on the most important one, number 1. And then yeah, the model that I use is actually like GBM. Gradient is a type of gradient boosting model developed by Microsoft, and it's free and open source. It's very fast, that's why I use it. All right, so this is my approach. So as you can see that the data has claim description, right? And I think all of us participants know that this is one of the key variable that will give us the most information, because it tells you about the claim itself. And however, when I train my model, I'm total noob, so I don't know how to use the model properly. And whenever I train the model, my model actually doesn't focus on claim description. So if I take apart my model and I look at the decision tree, or I look at the feature importance, claim description, the text bit is never at the top. It doesn't really rely on that information at all. So it got me curious on how can I force my model to focus on this variable, to learn something out of it, right? And yeah, this is the brute force approach that I thought about. So the brute force approach that I thought about is like this. I divide my data into multiple overlapping subsets. So for example, subset number 1, it contains all the claim that has the word rash in it. And then subset number 2 contain only all the claims that have the word spider in it. So spider bites and all that. And likewise, claims number 3, all the claims that contain arm, be it wounded arm, swollen arm, whatever. And on and on. There will be about 200 of these subsets. So another aspect is that they are overlapping. So if you can look back at subset number 1, row number 3, there's a spider rash there in the word. So this particular claim will also exist in subset number 2. So with my data divided like that, and then I will start training. So I would have one model for each subset. So I have 200 subsets, right, of data. I will also have 200 model. but it's actually very simple. All this model is actually the same model. It's identically built. The only difference is that it fits a different data into it. So yeah, I think it works magically for me. And this is akin to like a divide and conquer strategy. So now that I have 200 models, they each sort of specialize in a certain type of claims, right? So subset number one, the model trained on it specializes on rash. So I think what this allows my model to do is that now it can focus on the conditional effect that rash have on all the other variables. For example, maybe rash, they have a certain claim inflation that is just so different from the rest of the other kind of claim. So the model can more easily pick up this kind of relationship. And hence, yeah, and from there, since each of my models specialize in certain subset, and then they will also predict on this certain subset for the prediction. So with my predictions, because as you recall, all these claims are actually overlapping. So the same claim would exist in multiple subsets, right? So there will be multiple prediction for the same claim as well. So I have to average all these prediction up. And although it sounds simple, I'm just averaging my prediction, but actually it's a very powerful concept. It's the jargon, I think they call it ensembling or bagging. And it's very powerful because I think it's akin to the wisdom of the crowd, where when we gather lots of independent opinions and then we average the opinions, the average will normally be better than all the individual opinions. So I think the idea is because as we average out the errors, the plus and minus errors will also cancel out each other. Hence, why the average is normally better. So it's the same approach here. I'm just averaging my prediction from independent models. So, and that's my final prediction I'll submit. So yeah, so this divide and conquer and then wisdom of crowd strategy, yeah, I combine them and it works quite well for me. And yeah, and it gives me one of the most significant boosts to my score. And this, yeah, there's 5 minutes left. Maybe I can talk about it a bit also. So another approach that I did was actually just fix all the errors in the claim description. There's a lot of spelling error in the claim. So for example, like finger is spelled wrongly and all that. So I just correct all the spelling. It's important because as you can imagine, right? So if there's 2 records, one record has the word finger spelled wrongly, and another record has the word finger spelled correctly. The model wouldn't know this 2 is the same claim about finger. So you have to correct it, and then now they can start drawing relationship between them. So it's quite important. And then moving on to this, another similar approach, modeling choice 2B is it's also built on the same concept that I'm just trying to build more links between all these claims. So this is actually akin to what Lily has shared already. It's the entity embedding that she has shared, but mine is more brute force. So I just try to use pre-trained word embedding BioBirds, and then I apply that concept, and I'll try to add more related body parts to my claims record so that the model knows, okay, maybe abdominal is closely related to stomach, something like that. And lastly, it's just a bunch of hyperparameters. There's trial and error, and I also click my outlier and all that. But yeah, and that's it for me. And thank you very much. Yeah, I think, yeah, if you have any questions, please feel free to post here. Thanks. Back to you, Frederick.
Thank you, Tiong. I think it's really great to see this morning that actuaries who are starting their journey, like Sarah, Suguru, Mikael, and yourself, are able to finish in the top 10 in a competition when you have hundreds of competitors, and they are not too far from an expert like David earlier or just now, Ili. So that's